Welcome back to our online lesson. In today's lesson, we're going to focus on exercise 4a, which is estimating the area under curve using rectangles. So to estimate the area of a curve, we're going to take the following example. So you have a graph of fx equal x squared plus 2, and we want to estimate the area between 2 and 6. So we're going to do that in 3 simple steps. The first step will be to find the area of the inscribed rectangles. The inscribed rectangles means the rectangle that lies inside under the curve, and the circumscribed rectangles are the rectangles that lie above the curve. So to find the area of the inscribed rectangles, we're going to use the left endpoints. Now, what are the left endpoints? If you look at rectangle 1, R1, it lies between 2 and 3. So 2 is called the left endpoint and 3 is called the right endpoint. Now, to find the area of R1 using left endpoints, we need to find the height of R1. And to find the height of R1, we find f of 2 because f2 gives us the height of the rectangle R1 when it's inscribed. So area of R1 will be f2, which is 2 to the squared plus 2 times 1, because the width of each of the rectangle is 1. So rectangle is length times width. So the width is 1 and the height is 6. So the area of R1 is 6. Similarly, to find area of R2, we use the left endpoints again. R2 lies between 3 and 4, so the left endpoint is 3, and the height of the rectangle when x is 3, you just replace x by 3 in fx, which is 3 squared plus 2, which gives you 9 plus 2, which is 11, and 11 times 1 is 11. So the area of R2, rectangle 2, is 11. Similarly, to find area of R3, R3 lies between 4 and 5. We're again using the left endpoint. Replace x by 4 in fx, so that gives us 4 squared plus 2, and the answer is 18. Last, to find area of rectangle 4, we replace x by the left endpoint, that is 5, and that will give us an area of 27. Adding up all the 4 rectangles, R1 plus R2 plus R3 plus R4, we'll get 62 square units. Now, the second step will be to find the area of the rectangles using the right endpoints. Now, if you look at the diagram again, for rectangle 1, it lies between 2 and 3. 3 is called the right endpoint. So to find the height of rectangle 1 using right endpoint, we sub 3 in fx, so that will basically give us the rectangle 1 using the pink ink. So it's like the bigger rectangle lying above the curve. So when we find f3, we'll get 11 times 1 again, because the height, the width of each of the rectangles is 1. Similarly, area of rectangle 2, if you look at rectangle 2 in the diagram above, the limits is 3 to 4. We're using a right endpoint, so we have to substitute 4 in fx. So by substituting 4, we'll get 18, and that goes on for the remaining rectangles. Area of R3 will be 27, and area of R4, so if you look at R4 in the diagram above, the right endpoint is 6, so you substitute 6, that will give you 38, with a total area of 94. Now, one is underestimate and one is overestimate. To find like a proper estimate, what we do, estimated area will be average of inscribed and circumscribed area. So the average area of those two, that is 62 plus 94, you average those two That will give us an answer of 78. Now we're going to look at the second method of estimating area under curve using the midpoint method. So, and then we're going to compare those two methods, which one is more accurate. So using the midpoint method, what we do is, for the first rectangle A, RA, we find the midpoint. The midpoint between 2 and 3, of course, is 2.5. So the height of rectangle A, we just replace 2.5 in fx. That would be find f of 2.5, which is 2.5 squared plus 2, which gives us 8.25. So the area of rectangle A will be 8.25 times 1, which is obviously 8.25. Similarly, to find area of rectangle B, the midpoint between 3 and 4 is 3.5. We replace x by 3.5 in fx, and that will give us 14.25, and 14.25 times 1 is 14.25. Similarly, area of rectangle C, the midpoint of 4.5 is 4.5. Replace 4.5 in fx and then times by 1, you'll get 22.5. And last, area of rectangle D is 5.5 squared plus 2 times 1, which gives us 32.25. Adding them all up, area of the 4 rectangles, that will give us 77 square units. Now, which one is a better approximation? Is that using the left and right endpoints or using the midpoint method? To do that, we're going to find the exact area of the curve between 2 and 6, which we're going to do in our next lesson. That's called the definite integral. So you antidiff fx between 2 and 6 in your ClassPad calculator, and that will give us an answer of 77 and a third. So by looking at the two free answers, one was 78 using the left and right endpoints. Using the midpoint, we obtained 77, and the actual area is 77 and a third, which means that the midpoint method is slightly better method. It's closer to the actual area. Now, how can we improve the results by using rectangles? That's the class discussion. Have thought about this question, and then we'll discuss that in our next lesson. Thank you.